Hello viewers on YouTube. In this video tutorial, we are going to focus on how you can express a recurring decimal in fraction. So before we try going over some examples problem, it is important for you to understand what recurring decimal is in essence. From the word recurring decimal is a decimal that has a particular or a certain digit to be repeating itself without ending. Take for instance, we have 0.11111 repeating. So this dot 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 signifies that this one continues without ending. This kind of decimal is called a recurring decimal because it has a digit that tends to be repeating itself continuously. Now, the main purpose of this video is to show you how you can express this kind of decimal in form of a fraction. So the process you need to walk through actually depends on your singleton. And what it is in essence is it depends on the amount of digits that is repeating. If the digit that is repeating that is recurring or that is continuous, if it is 1, then the process you will take will be different to the digits to a kind of situation where you have up to 2 digits that's repeating or that of 3 digits that's repeating. So let's start with this kind of scenario. So if for instance we actually want to express this in fraction, what are the process we need to walk through? The first step is you representing the recurring decimal to be a variable. So you can use any variable of your choice. So for this problem, I will consider using x. So you begin by letting x to be equal to the recurring decimal 0.111 continuously. Perfect. Now before I actually move to the next step, I need to show you another way in which this can be expressed. Sometimes you might have it like this, where you have some sort of dots to end it to show that it's a continuous number. However, some other time they might just express it as 0.1 raised to power bar or 0.1 bar. When you see something like this in the entire class of fraction, then it means the 1 is repeating itself or the 1 is recurring. In fact, this can be expressed as 0.1 with the dot on top of the 1. It's not I, okay? It means the 1 is repeating itself. So whichever the case might be, just know that this is what will make sense. Excuse me. Perfect. So right now, having letting x or whatever variable of your choice to be equal to that recurring decimal, then do you want to multiply both sides of this equation by 10? The reason why you are multiplying by 10 is because you only have 1 digit to be repeating itself. When we consider examples that involves 2 digits to be repeating itself, we won't multiply by 10, but instead something else. But that is not for this video. So multiplying both sides by 10, we have 10 times x to be equal to 10 times 0.1111 repeating. Perfect. So right now, for the left hand side, we have 10x. And for the right hand side, 10 times 0.111 would actually shift the decimal points just 1 unit to the right. And then we have 1.111, okay, continuously. Am I communicating? Perfect. So basically, we can let this be our equation 2. Let this one be our equation 1. So what I want to do right now is I basically want to take equation 1 and move it closer to equation 2. Let me just write it below it and have x to be equal to 0.111 repeating. Now, at this junction, you basically want to subtract equation 1 from equation 2. And please, I want you to pay full attention on how I'm going to be subtracting the equations, as you have to be very careful. If you already know how to subtract decimals, then you can just take your time, but nonetheless still pay attention. So now 10x minus x, we are subtracting equation 1 from equation 2. So 10x minus x is simply 9x. Perfect. But this is where the work is. When we subtract decimal, we make sure that the decimal point is actually in line. So it means you subtract whole number from whole number, decimal fraction from decimal fraction. You must make sure that you arrange those values in such a way that the decimal point is in line, such that we will be subtracting decimal fraction from decimal fraction, whole number from whole number. They must not be mixed up so as to end up having the right answer. So basically, 1 minus 0, they are both whole numbers, right? It's simply 1. And decimal point has to follow. So we have point. Now, as you can clearly see, this is 0.11111, and this is also 0.11111. By the time you subtract them, they will eventually cancel out because they are actually the same. So this can become 0. And finally, since our goal is to isolate x, we can divide through by 9. Thus, we will have x to be equal to 1 divided by 9. This is 1.0, which means you can always express it as 1. Now, if you confirm it using your calculator, 1 divided by 9, you will realize that you will end up having 0.111 repeating continuously. And this is how you can easily express a recurring decimal in fraction. So this clearly means that 0.111 recurring is simply 1 over 9 in fraction. Simple as that. For better understanding, let's consider a few example problems. On to example number 2. So consider the recurring decimal 0.7 dots. If we are willing to express this in form of a fraction, our first step is to set x to be equal to 0.7. So basically, I would like to write it out as 77. And next, I will end it with dot. Then at this point, I want to confirm the amount of digits that tends to be repeating. Well, since it clearly shows that it's just one digit that's repeating, it means I'm multiplying the both sides of the equation by 10. So if this is my equation 1, then multiplying equation 1 by 10, you can actually write it in order to show what you are doing. In order to show that you understand and you know what you're doing. So multiply both sides by 10. Then we have 10 times x to be equal to 10 times 0.777. So 10 times x is 10x, and 10 times 0.777 would just, we still continuously, we'll just shift the decimal point just 1 unit to the right. Thus, we have 7.777 continuously. Am I communicating? Perfect. So now, just like before, this is 10x and not 10. Let's bring the equation 1 closer to equation 2, because this can be considered as equation 2. So if we bring it all the way down, we have x to be equal to 0.7. I don't know what's wrong with my tablet. 7 repeating. Equation 1. So now subtracting equation 1 from equation 2. 10x minus x is simply 9x. So we have 9x to be equal to 7 minus 0 is 7. Perfect. Then we have 7 point. Now all these will actually get rid of themselves. We have 0. 0.777 minus 0.777 will get rid of themselves. And upon dividing through by 9, x would be 7 by 9. And that would be the corresponding fraction to the recurring decimal 0.777 repeating. And that's it, guys. How by now you have been developing your understanding in this lessons. So on to example number 3. By the way, feel free to pause the video and try this out yourself. So we have 1.25 repeating. Okay. So just like before, let x be equal to 1.25. Now since this 5 that is repeating, let's repeat it a little bit. Okay, and end it with dot 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 dot. Basically, we're trying to extract it out. Understand? Perfect. Now, the next thing is to confirm how many digits is repeating. Well, we just said that earlier that 5 is repeating, it's just 1 digit. Thus, we are multiplying both sides of the equation by 10. So, if this is our equation 1 by 10. So multiply equation 1 by 10. Thus, we now have 10 times x to be equal to 10 times 1.2555 repeating. And if we simplify that, 10 times x is 10x, excuse me, and 10 times 1.25555, we just shift the decimal point 1 unit to the right, and then we have 12.555 repeating. We are communicating, and we can call that our equation 2. Now, you have to be very, very careful at this point. Very, very careful. Just watch, listen, and listen carefully. So now, just like before, let's bring equation 1 all the way down, and then we have it as x to be equal to 1. Remember, when you want to write it, make sure that decimal point is online. We are writing 1 digit. You're writing 1 digit, very careful. So don't put this 1, don't put it at the position of 10, because for this upper one, the one we have here is a 10th value, while this 2 is a unit value. But remember, for this one, the one we have here is a unit value. So please make sure they are in line. Don't put it here. Remove it from there. Put it at the position of the units, so as to make your subtraction process very straightforward and without any silly errors. So we have points right there, right? Perfect. Then we can list out the rest. So that's 2, 5, 5 repeating equation 1. So at this point, you can now take your subtraction, right? 10x minus x is simply 9x, and this is equal to, so we are doing 12 minus 1, or probably you can do 2 minus 1, that's what? That's 1. And then it's like, you can see this as 0. 1 minus 0 is 1. Am I communicating? Perfect. So we have our decimal point. Now, from here all the way down, we'll cancel from here all the way down. So we need to subtract 5 and 2. 5 minus 2 is simply 3. So upon dividing through by 9, we would have our x to be equal to 11.3 divided by 9. Now, we are expressing a decimal in fraction, so we must not have decimal at the end of the day. So if this kind of cases occur or take place, it's advisable to multiply both the top and the bottom of your fraction by 10, so as to get rid of decimal entirely. And you use 10 if it is at one decimal place. You can see this is just one decimal place, 11.3. If it's at two decimal place, then you multiply by 100, because just like that. If it's at 3 decimal place, you multiply by 1000 and so on. So multiplying 11.3 by 10, we have 113, and 9 by 10 is 90. So therefore, this is our final answer. However, you can also confirm if you can actually simplify the fraction notes. But I don't think there's anything that can actually reduce 113 and 90 at the same time. So therefore, that gives us the solution to 1.255 repeating. Am I communicating? So the corresponding fraction is 113 divided by 90. So guys, this is how you can easily express a recurring decimal that simply have just one digit to be recurring into a fraction. So in our next video, we are going to be considering when we have up to 2 digits to recurring itself in a recurring decimal. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. So this is the exercise I have for you. Feel free to share your solution with me via the comment section below. So consider expressing the recurring decimal 11.381 bar into a fraction. I'll be expecting you to respond. Thank you once again. Bye for now.